going through the October-November 2023 or the October 2023 Mechanics M1 paper from Pearson's Edexcel International A-Level. You will be seeing this video probably just after October 2024. Previously, they would lock the papers for 9 months after the exam was sat. Now they're going to, or they've started to lock the papers for 1 whole year after the paper sat. So I'm not able to upload these videos until after a year from the date of this exam being sat, and that's when it gets unlocked on the website. And otherwise I could be liable for copyright strikes. So that's the reason why you won't be seeing this video until then. Nothing I can do about that, but that's how it is. So my channel almost got closed down actually last year because of this. It wasn't very clear actually at that time, especially with the Cambridge stuff. So anyway, it got sorted out, but I'm sticking very strictly to the rules. So excuse me if that's an issue, but there's nothing I can do. Anyway, so I'm going to go through this paper, and I'm going to go through it in such a way that if you have not studied mechanics before, that you should be able to learn a lot of the basic stuff, and start picking up from there, and hopefully salvage a good grade if you have some issues with mechanics up to now, you haven't studied, or you haven't had opportunity to study at school, or whatever reason. I'm going to try to help you so that you can learn from the foundation upwards. So don't, if you're one of those students who are really good, and you basically are just trying to see if you answered it correctly, and you want me to be just like a mark scheme talking and not go into any details because you already know the stuff, then this is not really the place for you. Okay, you can find a mark scheme or somebody who just talks through the mark scheme. I'm going to actually explain some of the issues and some of the fundamental ideas, especially keeping in my mind some of my own students, the type of questions they ask me. Sometimes I use these videos to address a particular doubt or confusion, and I use these videos to kind of address them. So those are the things in my mind when I'm explaining the videos. I have a specific purpose for making these videos. It's not just like it's to help me teach my students. Basically, it's like a teaching tool that I'm using. So that's why sometimes I do go into some detail. So please bear with me. If that's not what you're after, you can find somewhere else to have a look at the mark scheme. Anyway, let's start. I'm going to save each video on a separate each question on a separate video, so I can save them according to the paper and also according to the topic. So the first topic looks like it's to do with statics and moments. Okay, so like it's got to do with moments from the way the picture looks. It says figure 1 shows a beam AB with weight 24 newtons and length 6 meters. So 6 meters long, the weight is 24 newtons. Now, right now, unless I have more information, I do not know where the weight is acting. Okay, I can't say 24 newtons acting exactly 3 meters along the beam. Okay, because from what I've read of the question so far, they haven't told us what type of beam it is. If it turns out to be a uniform beam, yes, the weight will act exactly halfway along the length. If it's non-uniform, then we don't know where it acts, and we have to either be told, or maybe we might be asked to find where it's acting. Okay. Now the beam is suspended by 2 light vertical ropes. So these ropes are light. Okay. That means we ignore their weight, which means the tension in the rope all the way from the top to the bottom is going to be the same. Okay, so that's really what the light part means. The tension throughout that section is going to be the same. The ropes are attached to the points C and D on the beam, where AC is X meters and CD is 2 meters. Then it says the tension in the rope attached to the beam at C is double the tension attached to the beam at D. So the tension in this rope at C is twice the tension in that rope. So that's good. We can have the 2 tensions in terms of each other. There won't be like 2 unknowns. Okay, it's like 1 unknown T, that's 2T. All right, the beam is modeled as a uniform rod. So that's what I was referring to. Now we know it's a uniform rod. Okay, we can say the weight's acting exactly 3 meters in. Okay, so we know that now. And it's resting horizontally in equilibrium. That means all the forces acting on it are balanced out. All the moments acting on it are balanced out as well. Okay, so it's in equilibrium, it's in static equilibrium. It's still, it's not moving, and it's not turning or tilting or anything. It's just in equilibrium. All right, so now we got to use that to find the tension in the rope attached to the beam at D and the value of X. So I'm gonna take this. I'm gonna make this a bit bigger so I don't have to keep scrolling up and down. All right. So we were told the weight. I need to scroll for that. The weight was 24 newtons. That's what I need. So the weight we know is going to act exactly through the geometric center of this, so exactly 3 meters in. So let's just say that's going to be somewhere like here. Just roughly, that's 3 meters in. So that's the weight, which is 24 newtons. Now we're going to write 24. Okay, we're not going to write G because sometimes they gave us the mass, this time they gave us the weight. So some people do ask, why don't you write 24G? Okay, sometimes they give the weight is W. Why don't you write WG? No, if they gave us the weight, that's the force. If they gave us a mass, the force would be the mass times G. Okay, in this case, we got the weight, so it's 24 newtons. That is the force acting. That's the weight of so what we're drawing here are the forces acting on the beam. What forces acting on the beam? And the forces acting on the beam are its weight and also the tension in the ropes that's pulling it upwards. So you got the tension in these two ropes. Now they told us about the tension in the ropes. They told us that the tension in the rope at C is double that at D. So if this is T, this will be 2 times T. Okay, so that's another bit of information we have. And what else do we know? All right, that's it, I think. Okay, so now we want to find the tension in the rope and we want to find the value of X. So let's start with number part 1. That's pretty easy because we know that it's in equilibrium. So the forces acting upwards and downwards are balanced out. So if we resolve the forces, all the forces acting upwards, you've got 2T plus T. And all the forces acting downwards is just the weight of the beam, which is 24 newtons. So 3T equals 24. So T is equal to 8 newtons. So the tension of the rope is 8 newtons. Okay. Now it says at T is equal to 8 newtons, and at D, the tension is equal to 8 newtons. It's just T. So that's fine. So the tension of the rope attached at D, yeah, that's fine. Okay. If the question had said find the tension of the rope attached at C, then it would be 2 times T. So then it would be 16. So at D, we know that T is equal to 8. So there's the answer. Okay. So now number 2. It says find the value of X. So we're going to find the distance of C from A. Now we've got a number of different ways of doing this in terms of taking moments. So I can take moments about any point I want to, and the moments that are the clockwise and the anti-clockwise moments have to balance out because this object is in equilibrium. It is in static equilibrium, right? So I can take moments about A. I can take moments about even C. I can take moments about D. I can take moments about the weight. I can take moments about B. Anywhere I want to. Right now, some people will take moments about a place where there is a force that is acting through that point. Okay, and you would normally do that when you have unknown forces. You're kind of forced to do that. In this case, we know that this is 8 newtons, and we know that this is 16 newtons. So we have no unknown forces here. All right. So we're not forced to take moments through a point where we don't know what the force is. Okay. So in this case, what I prefer to do, if I have the choice like that, is I prefer to take the moments about the point from which you want to find the distance that you are looking for. So I want to find the distance from A to C, which is a value of X. So I'm going to take moments about A. That's what I prefer to do. So I'm going to take moments about A. Okay. So if I take moments about A, I consider the clockwise moments first. It's up to you what you want to do, but I consider the clockwise moments first. I know that this distance here of the weight of the beam is basically exactly 3 meters in from the end because it's a uniform beam, so it's exactly in the geometric center. That's 3 meters. So the clockwise moment is 24 newtons times 3. The other two forces, if A is the pivot, would be anti-clockwise because they would cause, if you were to pull up these two strings and this is the pivot, it would kind of like go that way. It would lift up that way if you were to do that. And for this one, if you were to pull down, it would go that way. So this would be clockwise, that would be anti-clockwise. Okay, so pulling upwards would cause it to go around like this. Pulling downwards on at this point here would cause it to go clockwise. So the clockwise is 24 times 3, and both of these two forces are anti-clockwise. So you have 16 times x. So 16 times x plus, and you got to have, this is going to be t, which is 8 times, and this is going to be x plus 2. That's x plus 2. All right, so that's the force times the distance. That's the turning effect of the force. So now we have only one unknown here, which is x. So we can find what x is by solving this equation. So 24 times 3, that's 60, plus 12, that's 72, equals 16x plus 8x plus 16. So 72 equals 24x plus 16. Take away 16 from both sides, so 72 minus 16. That's going to be 72 minus 10 is 62. So that's 56 equals 24x. Therefore, x equals 56 over 24. So let's see how good my mental maths was there. So we have 72 minus 16, 56, good, divided by 24. And that gives us 7 over 3. Okay. So you can leave it as 7 over 3. So x equals 7 over 3 meters. You could also write it as x equals 2 1/3 of a meter. You can write it as x equals 2.33 meters. All of those are perfectly fine ways of writing your answer. You wouldn't round to 3SF here, to 2SF here, because we didn't use G. We were given the weight as 24 newtons. We didn't use G. So if you were to round to 2SF here, you would definitely not get the full marks. That's why it's always safer to round to 3SF. As if you see the beginning of the question in the paper, it says, whenever a numerical value of G is required, take G equals 9.8 and give your answer either 2 or 3 significant figures. So if you give it to 2 significant figures when you've used G, that's fine. And you see, they said also 3 significant figures when you use G is also fine. Okay, technically it shouldn't really be because you use this at 2SF. So your answer should really be to 2SF. But because of this statement here, the safest thing to do in all of the mechanics questions is to leave your answer to 3SF because of this statement here. So even here, so some people might say, oh, we've used the weight. Let's put it to 2SF. But no, we have used the weight in terms of what? In terms of W. They gave us the weight. They didn't say, M, and then you put G there yourself. So here, you have to write it to 3SF, or personally, I would leave it in either of these two forms, and that's fine. And that completes this question. All right, that's the end of this question. Now, just to make it clear to everybody, I want to make sure that you understand, that it doesn't matter where you take moments about. Right? You can take moments about anywhere you wish to. So, for example, I could have taken moments about B. And if I took moments about B, for example, then the clockwise moments would be these two, and the anti-clockwise moment would be this. And the distance of, it makes things a bit more complicated, that's all, right? It makes things a bit more complicated, but it still would work, right? So the distance here would be, for example, this would be the total distance 6 minus x plus 2. This distance will be 6 minus x plus 2, which is going to be 6, it will be 4 minus x. That will be 4 minus x meters. Okay, and the distance from here to here would be 6 minus x meters, because you got 6 minus the whole thing minus this x. And the distance of the weight from there would be 3 meters still, because halfway. And we're taking moments about B. So if we took moments about B, okay, I'm just illustrating this to you, not that this is a good way of doing it, but just to show you it doesn't matter where you take moments about, you'll get the same answer. So we'll have the clockwise moments, which would be 16 times 6 minus x, plus you'll have 8 times 4 minus x equals, then these would be those would be the clockwise moments if you took this as a pivot, because those would lift them up and go around this way, and this would go that way, which is anti-clockwise. That's going to be 24 newtons times 3. So you say you get 16 times 6, which is, that's going to be 60 plus 36, 96 minus 16x plus 4x, so 32 minus 8x equals 24 times 3. That's going to be, as we found earlier, that's 60 plus 4, 72. Okay, so you have 96 plus 32, that's going to be 128. You have minus 16x minus 8x, which is minus 24x, equals 72. So you have 128 minus 72 equals 24x. So that gives you 56. 128 minus 72, just to illustrate where the weight's acting. Okay, so I can say that this distance would be, that's 3 minus x, and this distance would be here, that would be basically, you can say that's 2 plus x minus 6. 2 plus, this distance here would be minus 3, sorry. 2 plus x, from there to there is 2 plus x, or x plus 2, and from here to here is 3. Okay, so it's x plus 2 minus 3, x plus 2 minus 3, which is going to be x minus 1. So that distance is going to be x minus 1, okay, from here to there. So we can see the clockwise moments. If this is the pivot here, the clockwise moments will be this way. Okay, the clockwise moments will be this way. So you have 16 times that distance, 3 minus x. And that's the only clockwise moments. And the anti-clockwise moments are only from this, because we're taking moments about this point. We don't have to consider the force that's acting to the point, because the moment of that force will be 0, because it's 0 distance from where the force is acting. So then you have on this side x minus 1 times 8. So it's 8 times x minus 1. So you have 16. In fact, we can divide both sides by 8. So you're left with 2 times 3 minus x equals x minus 1. So we have 6 minus x equals x minus 1. So we end up with 2x equals 6 plus 1, which is 7. 3x. My bad. Let me fix that. We have 6 minus 2x equals x minus 1. That's what happens when you do things in a hurry. You add 1 to both sides, that's 7. You add 2x to both sides, that's 3x. So we're left with x equals 7 over 3 meters, which is exactly the same thing that we got. Okay, so it really doesn't matter where you take moments about. This is actually quite an easy way of doing it. It's just getting the lengths in terms of x that maybe some people find tricky. So it really doesn't matter where you take moments about. Anywhere along the beam you can take moments about, as long as you can know what the distances are in terms of the x, you will get the right answer. Okay, so that's just to illustrate that to you. So there's multiple ways of getting the answer for this. That's why the mark scheme sometimes has lots of different ways of showing how to get these answers. All right, so I've put it in this particular way here, okay, which I've shown, but any of those ways are perfectly fine. So I just wanted to illustrate that to you. So I know it took a bit long doing this question, but that's because, as I said, I'm using this as a teaching tool for my students to make them understand certain important points. So if you would like to see other questions from this particular paper, you can go to the playlist, because this video is going to end at this question. And the other questions will be found in the playlist that you can find by clicking on the link that will appear at the end of the video in this region over here. Other questions which are involving moments from M1 Edexcel, you can find those in this playlist that will be linked over here. You can subscribe to my channel by clicking on this link, and you can watch the video, which helps you to see or use my channel to find what you need easily. Watch the video that will appear over there. Thank you for watching, and see you soon.